and good morning, and welcome to the Astra Society live stream of the Perseverance Mars mission. This is NASA's 2020 Mars mission, sending the Perseverance rover to the Red Planet. Launch is scheduled for today at 11:50 a.m. Universal Coordinated Time, or 7:50 a.m. local time. Launch window is 2 hours long, just in case there is a issue with the launch vehicle and we will have to postpone today. This is going to be the final of 3 Mars missions for this year. It is following the Hope Mars mission and Taiwan 1 mission. The Perseverance rover is a sister rover to the Curiosity rover, which launched 8 years ago. You are looking live at the Atlas 541 at Slick 41 at Cape Canaveral in Florida. It's going to be the 58th orbital attempt for this year, and the 85th flight of the Atlas V, and the 7th flight of the Atlas V in the 541 configuration. This will also be the 140th mission for the United Launch Alliance. Currently, the rocket is being fueled with the cryogenic liquid oxygen and liquid hydrogen powering the Centaur upper stage. RP-1 was loaded onto the booster over a month ago during the wet dress rehearsal. We are hoping to give you better views once the official webcast starts here in just about 2 minutes and 30 seconds. So about the Atlas V 541 configuration. The name Atlas V 541 refers to the 5-meter wide fairing, which is the nose cone at the top, 4 strap-on AJ-60A solid rocket engines, and 1 RL-10C engine on the Centaur second stage. The Atlas is the first stage, so below the cone at the very top, that is all Atlas. Atlas is powered by an RD-180 engine fueled by cryogenic oxygen and rocket propellant 1, or kerosene. The RD-180 is derived from the Soviet RD-170, the most powerful rocket engine ever made. The Centaur upper stage is enclosed inside the payload fairing and will be exposed to space just about T plus 3 minutes into flight. And Centaur is powered by liquid hydrogen and liquid oxygen and propelled by an RL-10C engine, which is one of the most efficient engines on the planet. Atlas V currently has a 100% customer success rate after 84 flights, making it one of the most reliable rocket on the planet. So going over today's mission timeline, at T plus 0 minutes, 0 seconds, we will have liftoff. Oh, and it looks like we have live coverage starting here in just a few seconds. So when that does come, I will be sure to, should be able to bring y'all that. Yeah. So at T plus 0 minutes, 0 seconds, we will have a liftoff with the RD-180 igniting to full thrust, and the 4. Uh-oh. Just give me a second. Gotta fix Discord. All right. So obviously at T plus 0 minutes, 0 seconds, we will have liftoff. And then at T plus 1 minute and 49 seconds, we will have SRB burnout and jettison. At T plus 3 minutes and 27 seconds, we will have fairing jettison. And it looks like we are starting to get live coverage here. Just a minute while I get that ready. Hey, can one of y'all on Discord link the official stream? All right, so we're going to go over what the Perseverance rover is. All right, so the Perseverance rover is, as we mentioned, the sister rover to the Curiosity rover. So the Curiosity rover, of course, launched 8 years ago and has been going strong on the red planet ever since. Perseverance rover is hopefully going to do the exact same thing today with a few more experiments. So starting off with the experiments, we of course have Mastercam Z, which is the multiple 2-megapixel cameras mounted on the mast of the rover, which is the tall part that you can see on your screen right now. This can take 3D pictures. Oh, and we are live with NASA TV. Let's listen into the live stream.
Welcome everyone. Behind us, the star of the show. This is a life-size mock-up of the Perseverance rover, which is just like the one we are launching to space. Hi everyone, I'm Daryl Nail.
And I'm Mujige Cooper. In the 50 minutes leading up to launch, we will show you how this mission will reach and search for ancient microscopic life on Mars and test new technologies critical to the ultimate goal: future human missions to Mars.
That's right, and we've got the rocket on the pad and it is ready to go. A beautiful day outside. We're L-47 minutes and counting until launch, and so far the countdown to Mars is on track. We've got great weather, the rocket's looking good, and it puts us on track for a launch at 7:50 a.m. Eastern Time, the beginning of a 2-hour window.
In today's coverage, we will hear Grammy Award winner Gregory Porter. We'll talk live with Derek Muller of the YouTube channel Veritasium, along with the aerospace engineers, scientists, and a NASA astronaut.
Oh, it's going to be a great show. Yes. I love it. I love it. And we have teams from coast to coast, folks, helping us count down to Mars. We will go live to the Atlas Spaceflight Operations Center, just a few miles away from us.
And we'll go live to California, to the Jet Propulsion Laboratory, where the Mars 2020 mission team is standing by to communicate with Perseverance after it gets to space.
And of course, we are here to tell you what the Perseverance mission is all about. It's an exciting day for all of us here. So we want to walk you through what you will see next during the countdown and the rocket launch. So let's send it over to Joshua Santora and Mick Waltman, who are with the ULA and Launch Services program teams. Gentlemen.
Hey, good morning, Daryl. I'm Joshua Santora, and I am here at Atlas Spaceflight Operations Center, joined by Mick Waltman from NASA's Launch Services Program. Mick, you excited to go to Mars?
I am excited to go to Mars this morning, Josh. This is a great day. The sunrise out there looks awesome on this rocket, and ready for a great launch today. Thanks for having me on the show.
Man, happy to have you along, providing a ton of good context as we go through. Before we dive into the story of Perseverance, we want to give you a preview of what's ahead today in the countdown. Things really got going this morning just after midnight, actually, and Atlas V is just about ready to fly. In a few more minutes, we're going to get the final check of the weather, and that weather report should be coming back really positive. It's been great all morning. We have the terminal count ahead after that. We will be proceeding through the last few minutes of the countdown, and then the drama will be at its peak at launch. When the clock strikes 0, the engines ignite, and the spacecraft and rocket take flight. After successfully passing through max Q just shy of 2 minutes into flight, the solid rocket boosters will be expended and will be jettisoned. Nearly 2 more minutes, and the payload fairing, what you might call the nose cone of the rocket that has been protecting Perseverance, will no longer be needed. It will split in 2 halves and fall away from the accelerating vehicle. 1 minute later, the Atlas booster will have finished its task of lifting Perseverance above Earth's atmosphere and being on the way to orbit. It too will separate, exposing the Centaur RL-10 upper stage engine that will almost immediately begin its first burn that lasts approximately 7 minutes. After coasting for more than 30 minutes, the second burn, lasting around 8 minutes, will take Perseverance out of Earth orbit and into solar orbit on its way to Mars. That sets up spacecraft separation and the final milestone we're hoping to hear this morning, the acquisition of signal. And I say hoping to intentionally because it's quite possible that Perseverance will be in perfect condition, but we won't make contact during the broadcast. So lots more to come, lots ahead. But Daryl, we're going to throw it back over to you now to tell us more about this amazing mission.
All right, thank you, Joshua and Mick. We've got a lot of really smart people and talented people that we're going to be talking to today. But let's begin with a scientist who's coming up in just a bit. I want to talk a little bit about Mujega Cooper, who's here. She is a planetary protection lead for this mission. Thank you so much. You've been working on this for a while, Moo.
Yes, this has been 7 years in the making, and I'm so excited to share this moment with you and with those that are viewing today. I'm just ecstatic.
It's fantastic, and we're in a launch period. People probably want to know, why are we launching today? Why are we launching right now? We're in a period that only comes around once every 2 years.
Yeah.
Explain that.
The orbits of Earth and Mars are on the same side of the sun so that we can reach that destination with less fuel. So it's the best time. Short journey, less power.
We like that. And we're studying the climate, the geology, and searching for ancient life. But Moo, what kind of life are we talking about here?
Well, when we search, we're not going to find dinosaur fossils, right? We're likely...
No.
Unfortunately. Likely we're going to find it in the form of...
All right, so we're going to go back over to some of the experiments that we are going to see on the mission. So going back, we have the Mastercam Z, which as you can see is the tall mast on the very front of Perseverance. This contains the multiple 2 megapixel cameras, 3D picture cameras, and video cameras. These cameras are almost exactly the same as what was on the Curiosity rover. Next, we have MOXIE, or the Mars Oxygen IRSU experiment. This is probably the most important experiment launching on this mission today. MOXIE is going to demonstrate the technology that could produce oxygen from the Martian atmosphere. This would be critical for future crewed missions to Mars, converting that carbon dioxide and nitrogen into the atmosphere into oxygen for us humans to breathe and live on the red planet. Next experiment that that one of the webcast members was talking about was Sherlock, the scanning habitable environments with Raman and luminescence for organics and chemicals. Gotta love those NASA acronyms. It's a UV spectrometer that determine the microbiology and detect organic compounds on the Martian surface. So if there was any past life on Mars, Perseverance will find it. And one of the final experiments on the rover is REMFRAX, which is the radar imager for Mars's subsurface experiment. This ground-penetrating radar will provide high-resolution images of Mars's geological structure, similar to what InSight is doing on the Martian surface right now. So going back to the mineralogy and organic compounds on Mars, there is a sort of mechanical arm actually under the rover that will go down to the surface and drill just a tiny bit of material out. This material will then come back up into the rover and be placed in a special canister where it will then be oxygen is overrated. So yes, these samples will be stored inside the body of the rover, so that when time comes for, as they were just talking about in the webcast right now, a sample return mission from the Martian surface, they will be ready. This is similar to what ESA's ExoMars is going to be doing, which was supposed to launch during the 2020 window, but unfortunately it is going to be delayed until the 2022 window. Another awesome milestone for this mission will be Ingenuity, which will be the first craft to fly in the atmosphere of another planet. So Ingenuity is going to be a small helicopter which will use a tandem rotor design similar to toy helicopters you would go and buy for $30 at the store, with one rotor spinning one way and one spinning the other way to counteract torque. produced by spinning a rotor in one direction. Ingenuity will be the first craft to fly in the atmosphere of another planet under its own power. It'll be amazing to see that. I can't wait to get videos of this. So going back to the rocket, it was going to be launching on the Atlas 541 rocket, which is an Atlas with a 5-meter payload fairing, 4 strap-on AJ-60A solid rocket motors, and 1 RL-10C engine on the Centaur second stage. Atlas V has a 100% customer success rate after 84 flights, which is incredible for the rocket. Almost no other rockets have had such a success rate. So again, the launch window opens at 11:50 a.m. Universal Coordinated Time on July 30th, 2020, which is today. Window closes at 1:50 p.m. UTC, again today, July 30th. Local time is 7:50 a.m. when the window opens and 9:50 a.m. when the window closes. This countdown that we have is targeting the very beginning of that window at 7:50 a.m. local time, which is Eastern time. This is going to be the third of 3 Mars missions that are launching this year. 2 have already launched, the Hope Mars mission for the United Arab Emirates and Taiwan 1 from China. The Perseverance rover is going to land at the Jezero crater on February 18th, 2021. This date will not change, actually, due to how orbital mechanics works. So no matter what, if we launch today or in a week, it will land on February 18th, 2021. We're launching from Slick 41 at Cape Canaveral, Florida in the United States of America. It's going to be the 58th orbital attempt for this year and the 85th flight of the Atlas V. It's going to be the 7th flight of the Atlas V in the 541 configuration. And this will be the 140th mission for the United Launch Alliance, which operates the Atlas V and Delta IV rockets.
Perseverance is a very, very profound first step in both our understanding of our face.
Here in the background, you can see that they are showing how Perseverance will help the future sample return missions, which will happen in 2026 if all things are go to plan.
Welcome back to the Kennedy Space Center in Florida, where our next Mars rover.
Let's tune back into the webcast.
And the man who leads the company tasked with safely getting Perseverance off this planet is Tory Bruno. He is the CEO and president of United Launch Alliance. We appreciate you being here, Tory, this morning.
Oh, happy to be here.
How is the launch team doing? How are you doing?
Well, the launch team is doing great. They've been on station for hours. They're calm, they're confident, they're going through the script. I'm a little nervous, but I always get nervous before all of my 400 launches so far.
Wow.
You get a little nervous. Why do you get nervous?
Well, you know, a rocket is such an incredibly powerful and complex machine. Everything has to go right. Nothing can go wrong. And it's just, it never gets old. It's always the same.
It's always exciting.
Yes.
And this is a particularly exciting mission. Talk a little bit about that. This is the largest and heaviest rover that we've ever sent to the Red Planet. So how did you configure your rocket to do this launch effectively?
Yeah, this is our second most powerful Atlas, the 541. We call it the Dominator. It's got 4 giant SRBs, each putting out 350,000 pounds of thrust to augment the center core. And so it has got the power to get out there to Mars, as well as the precision. It's the most accurate rocket in the world, because when we let it go, it's got about 200 million miles to travel on that transfer orbit.
And precision is key.
That is right, yes. So the power source for the Mars rover is a contained radioactive battery. I've seen it up close, and we had to alter the way we behaved around that.
Yes.
How has that changed your team's efforts?
Oh yes, the operations around that are completely different. Now we have a lot of experience with these. We've flown all of America's RTGs, and we're the only provider that is certified to handle them. But you know, it is still 11 pounds of plutonium, as you saw. And in this particular case, the one very special thing was to install it in the VIF, where we would normally never breach the containment around the spacecraft because it has to be clean and biological free. But we created a portable clean room and brought this nuclear battery out and installed it in the machine while keeping everything perfect.
Awesome. Can you explain what the VIF is, actually, before I let that go?
Yeah, the VIF is the Vertical Integration Facility. So these rockets are so gigantic, we build them in a factory, but we can't assemble them there. Atlas and Perseverance are standing 20 stories proud right now on the pad. So they come to Canaveral in pieces on our rocket ship, and then we assemble them in the Vertical Integration Facility. And normally the last thing would be to bring an encapsulated, under the fairing, perfectly clean and prepared spacecraft and put it on top, which we did, but then we opened it to install the MMRTG battery.
Yeah, that came late in the process, and that was intentional.
Yes.
You mentioned there's a certification for who certifies the rocket?
So NASA certifies the rocket, and then NASA and the Department of Energy certify a provider like us to handle a nuclear payload because of all these special requirements.
Very good. You know, when you were preparing for this mission, you couldn't have imagined, a year ago that you would have a coronavirus pandemic wreaking havoc on this state. How did you handle that, and how did you overcome it?
Yes, well, you know, the one big lesson learned here is you can't buy back time. So when this broke out, our response was early, it was aggressive, and fortunately it was effective. So we did all the things you might be familiar with. You know, we wipe down every surface every hour, we deep clean every evening, we are wearing PPE, we have our teams spread out, we actually change the flow of the work to keep our people safe, but to also keep these vitally important missions going. And of course, I can't say enough about our team. They're so disciplined and so courageous to persevere through all of this, and now to make our third launch under all of these mitigations. I'm just so proud of them.
Well, Tori Bruno, CEO of United Launch Alliance, we appreciate you being here, sharing your knowledge with us. Good luck with the rocket launch today, and enjoy it.
Thank you very much. Go
Thank
Atlas,
you.
go Perseverance.
All right.
The countdown to Mars is well underway. Let's go to our launch commentator team for an update on the pre-launch efforts and a weather forecast. Joshua?
Hey, thanks, Moo. Operations this morning have been really pretty quiet. Mick, can you tell us what's transpired to get the rocket to the point that it is today, right at this moment?
Yeah, actually, Josh, it's great to have a quiet countdown this morning. That means really good things for us here in the ASOC. But the teams did come on station today about midnight. They got on station, started configuring the launch vehicle, getting it ready for fueling, as we've been listening to them fuel the first stage Atlas with LOX and the second stage Centaur upper stage with cryogenics. The team continues to do that. They've checked out the avionics, the electrical systems. They've also done a flight termination system check with the range. So all systems are looking nominal, and the team is now currently in their T-4 and holding, and just assessing the telemetry and the launch vehicle as we get ready to lift off this morning.
Yeah, and it is a programmed hold, so this is part of the plan. This is not anything going wrong. We do have a 2-hour window today, but everything is charging ahead towards that 7:50 a.m. Eastern liftoff time. We want to introduce you to a few of the teams involved this morning. We want to start with the U.S. Space Force. They're responsible for the range operations and weather activities. So, Mick, tell me about the range really fast before we get this weather briefing in just a few seconds.
Yes, the United States Space Force is responsible for public and personnel safety here at Cape Canaveral Air Force Station and Kennedy Space Center, where we're launching from. So a very important part of the mission today. They are one of 5 teams that are working with us to launch Mars Perseverance on its way this morning. And an important part of that, not only public safety, but is they also do weather for us to make sure that everything looks good. As we saw that sunrise this morning come up right behind, everything is looking good. So.
And we are at T-minus 30 minutes to launch.
Conduct weather briefing.
Everything is green on Atlas. awesome shots of the pad there. The
Sorry,
Atlas V
we thought we were going to get that for you live, and
Wow,
apparently the audio is on another channel. Forgive us.
You should be looking at a
You can
visible
see that
satellite
liquid
image. We
oxygen
have
being
now moved
vented there in between the first and second stages. That is, of course, normal. Everything is all right. This rocket is not on fire.
southeast, which has dissipated, so things are looking great for launch.
So
We are
here in
go
just
on
a
all
couple
LCCs and expect
minutes,
to
if we can, we're going to try to get you guys a graphic showing the Perseverance rover and how it is configured inside the rocket.
for the
So
cumulus
we'll
cloud
bring
roll.
you that view here in just a few minutes if we can.
This concludes the weather brief unless there are any questions.
So we just got a weather update. Weather is 90% go on the rocket today. We are 90% go for launch, which is amazing. I think I've seen weather like that in a very long time. So it's very good news proceeding into terminal count here today. Weather is at 90% go. I believe top concerns are some morning land breezes coming from the ocean, but other than that, we should be all right. Upper level winds are looking good.
In the procedure, this time has built-in holds in it, one of which we're in right now, 30-minute hold, which allows the team to adjust things that they need to do throughout the countdown tonight. So the L clock will continue counting down, and what's unique about this is at L-4 or T-4 as we pick up the count.
So going back over some of the experiments that are going to be on Perseverance. Perseverance is, of course, the sister rover to Curiosity, as that's pretty apparent given its shape. So, of course, being Curiosity, it has to have the tall camera mast on the front, which is called the Mastercam Z. The multiple 2-megapixel cameras capable of taking a wide panoramic shot around the rover. You can see a beautiful shot of Atlas there on the pad. You can see that crew access arm for Starliner, which future American astronauts will climb aboard the next American spacecraft. So going back to Perseverance, another experiment is MOXIE, the Mars Oxygen IRSU experiment. This is probably one of the most important experiments launching on Perseverance today. It's a demonstration of technology that could produce oxygen from the Martian atmosphere, which is full of carbon dioxide. This is going to be critical for future crewed missions to Mars, which can't bring their own supply of oxygen. Another experiment is Sherlock. This experiment is going to be a UV spectrometer that will determine the mineralogy and detect organic compounds on the surface of the red planet. This will also include a sort of drill that is positioned on the underside of the rover, which will take surface samples of the mission, or of the surface. And then there is RIMFRAX, which is a ground-penetrating radar that will provide high-resolution images of Mars' geological surface, similar to what the InSight lander is doing right now.
The beautiful baritone voice of Grammy Award-winning singer Gregory Porter. That was outstanding.
It was so emotional.
If
really
I
great.
could launch the rocket right now after that, see some rockets, red glare, I say it's perfect. Thank you very much, Mr. Porter. We appreciate that. So, Perseverance will seek to unlock many mysteries about Mars, but remote scientific instruments can only go so far.
Joining us now to talk about returning Mars samples
All right.
back to Earth is Dr.
Beautiful singing there of not the American national anthem, but very good American song. All right, so here we're going to show you how Perseverance descent will work, and we have a graphic which is going to be put up here in just a second. Yes, there we go. So here we have Perseverance, how it is stored inside the rocket. So actually, Perseverance is stored upside down on the rocket, heat shield facing up. So the cruise stage is attached to the Centaur upper stage at the top. Next, we have the back shell, which will protect the spacecraft as it descends through the Martian atmosphere. So you need to have a heat shield under your rocket, but you need to have something protecting it on top from all the from the plasma that will be generated from the intense heat. Then we have the descent stage, which will be disconnected from the back shell after the parachute has fired and slowed it down. This descent stage will does contain the 8 rocket engines that will bring the Perseverance rover slowly down onto the Martian surface. Once the rover gets really close to its surface in the zero crater, it will be winched down on a sort of crane. This is going to be the same way that Curiosity was winched down on the red planet. Once the rover soft touches on the surface of Mars, the descent stage, or called the sky crane, will ignite its engine full throttle and just fly away and get as far away from the rover as possible so it doesn't damage it. And then the science on the red planet can begin.
This is a really complex mission. It's going to require 2 launches from Earth and 1 launch from Mars in order to get those.
Alright, so we're going to try to get you some live views of the pad here in just a minute. We try to get this graphic up. Stand by. There we go. I just want to give a shout out to LC123, who is controlling all of the graphics in here on the stuff on the live stream today. Of course, on just our end. He's smiling at me in Discord. So yeah, if you want to go check out his channel, it's linked here in the description. He does launch live streams of pretty much any launch that has a live stream. He's going to cover it. Some awesome live views of the pad with the Atlas V sitting proudly awaiting its launch here in just about 20 minutes and 45 seconds. As we mentioned just about 10 minutes ago, we got our weather update. Weather is go. We are 90% go for launch today. That doesn't mean 90% of systems are go. However, we have a 90% chance of actually launching today due to weather. If for some reason we are in that 10% chance, our backup window is tomorrow at, I believe, the same time of 7:50 local time. So here we're going to tune into the webcast until just about T-minus 10 minutes in the launch to bring you some launch views.
Joins us now to talk about the set of milestones Ingenuity needs to hit in order to take flight on Mars.
Hi, by the way, we just had an earthquake in this room. But anyway, with that, Mars Helicopter Tech Demo is motivated by the potential of adding the aerial dimension to space exploration. In the future, a helicopter can serve as a scout for rovers and astronauts. A helicopter can get us to places of high scientific interest that cannot be reached today. It's not easy to build a rotorcraft for flight at Mars. The atmosphere there is very thin, about 1% compared to that at Earth. So a helicopter for Mars has to be very light and have a rotor system that can spin very fast. Behind me is the full-scale model of Mars helicopter Ingenuity. It's very light, 1.8 kilograms, about 4 pounds. It's capable of flying through the thin atmosphere of Mars and is capable of surviving and operating autonomously. There is a set of milestones between now and Ingenuity's first flight. The very first one is when we turn on the helicopter and the base station to check their health. First time operating in true space environment. The next major milestone will be when Perseverance rover deploys Ingenuity helicopter to the surface. The deployment will also mark the first moment the helicopter starts to work on its own in a standalone manner. It will never return to the rover. And the first major milestone then will be the helicopter surviving the first cold Martian night, about minus 90 degrees Celsius. And we've designed the helicopter to keep itself warm. So we've planned for up to 5 flights in the 30 Martian days that have been set aside for our flight experiments. The flight data we get from the helicopter will inform our team the health of the helicopter and performance of each flight. The data could also include a few color photos. First ever photos of Martian terrain taken from aerial vantage. That would be true icing on our cake.
Cake, Mimi, thank you. And you're right, we did have a little bit of a shakeup, but everything seems to be okay right here so far. And we look forward to Ingenuity's first flight. And with that, let's head back to KSC as we continue the countdown to Mars.
All right, thank you, Raquel. When the name Perseverance was chosen for the rover, our country was in the early stages of the COVID-19 pandemic. Now, the name is also a fitting description of what NASA teams needed to get this rover to the pad on time. Joining us now is NASA Administrator Jim Bridenstine. Thank you very much for being here, Jim. Perseverance is meaning a lot, and that includes recently a 3.9 earthquake that we have reports of in California.
Yeah.
We just saw our own Mimi on. She said things were rattling there. So we are persevering a lot.
Good thing we're not launching from Vandenberg today.
You're absolutely right about that. Things looking good here in Florida. I want to ask you, why did you choose to move NASA forward on this launch in the midst of a global pandemic?
Oh, well, there's a number of reasons, but I think the biggest thing is, the public wants to see the United States of America and our international partners do stunning things. And we have a history of doing amazing things in the most challenging times, and this is no different. So look, here's the other challenging thing with Mars in general. We can only go to Mars once every 26 months when literally the planets are aligned, and if we miss this launch window, it would cost us $500 million to store this vehicle for the next 2 years. And so there's a lot of reasons to go forward. Some of it is financial, the NASA budget. And then the other big reason is Americans want to see us continue to do big things. I want to be really clear though. We have made sure that all along this process, if somebody didn't feel comfortable working on this project, they had the option to not work on this project. And I will tell you, we didn't find that very often, if at all. Mm-hmm. I will also say that our highest priority was the safety of our people. And we wanted them to know that if they come to work, they're going to be safer at work than they would be if they stayed at home. And of course the personal protective equipment, the social distancing, the changing of schedules in order to minimize people working on the vehicle at one time. All of these things were put into place as protective measures. But it is true, the name Perseverance, which was given to this robot by Alex Mather, who's a 7th grader in Virginia. Mm-hmm. This is all about perseverance, and going to Mars, as you said, going to Mars is all about persevering in general. Doing it now is more persevering than ever before.
Real quick, we've got a launch, of course, counting down. How are you feeling?
Well, nervous as always. This is a lot of money at the top of a rocket, and of course not just the money, but the entire life's work of so many, thousands of people. So look, it's going to be a good day. We're knocking on wood. Right. But it's going to be a good day for NASA.
Thank you very much for being here, Jim. Appreciate your leadership.
Thank you. You bet.
All right.
Thank you so much. We are now at L-14 minutes and counting. Let's check back in with Joshua and Mick, get an update on preparations to launch the rocket. Joshua, there's an important poll by the Launch Services Program happening soon, right?
Yes, absolutely. So the countdown is continuing. Obviously, a status report, we heard them talking about the earthquake, and everything is still good. We're hearing that on the back end that things are proceeding well. No no major issues or hiccups because of that. Everything going well. The savvy viewers out there will notice the clocks in motion, 2 clocks actually. The countdown clock there behind Daryl and Moo is at 4 minus and holding. Excuse me, at T minus 4 minutes and holding. But the clock on your screen now is the L clock, and that is continuing to count down towards that 7:50 a.m. liftoff time.
Yeah, that's exactly right, Josh. As we talked earlier, the L time is the real-time clock that continues to count down to 0. At T minus 4 and counting, the 2 clocks, the T clock and the L clock, will sync up as the team continues to work their operational sequence events and the procedure. So the team is very focused this morning. As you already mentioned, the earthquake that was brought up, the team has assessed that and looked at it, and they're doing a great job and getting us to 0 this morning. So
we mentioned the U.S. Space Force as one of the 5 teams earlier, and next up we have the NASA Launch Services Program team responsible for managing the launch, and we're going to hear a poll here from the NASA launch manager himself, Omar Baez. He's going to poll his team for their readiness to be able to report out in just a few minutes. So he's very punctual, so this should be coming right on time here in just a few seconds. Let's listen in now.
This is the NLM on the NLM net. Currently working, no issues on range or the launch vehicle. Weather is green, 10% chance of violation, and winds aloft look good for the entire window. The spacecraft did experience some earthquake activity at their control center in Pasadena, but appears to be ready to proceed. And with that, I would like to poll the team for final launch poll and spacecraft configuration. NASA CE.
NASA CE is go.
SMA.
This is the final go poll for launch.
SMD.
SMD is go.
NASA Mission Manager.
NASA Mission Manager is go.
LSP.
LSP is go.
Copy. NASA team is ready to proceed.
All right, so we heard NASA team is ready to proceed. He even mentioned the weather in there, which is great, only a 10% chance of violation. Again, a big thank you to Jessica Williams of the U.S. Space Force 45th Space Wing.
I like the fact that we're working no issues this morning into this count. That's an important part that Omar brought up. And the team, one thing you need to understand about the NLM is it's a combined NASA team of spacecraft and engineering. So hearing all those goes is good this morning.
Yep, and we're going to keep moving because we got a lot to do still. We're going to throw it back out to you, Daryl.
All right, thank you very much, Joshua. Our NASA teams across the country overcame challenges caused by the COVID-19 outbreak, as you've heard so far, to get this Mars rover to the launch pad on time.
We are about to hear from workers at centers in California and Florida who took every imaginable precaution while managing to get this vital work done.
When I saw the country shutting down, I thought for sure there is no way we're going to be able to continue this.
It's something that nobody expected. It's something that nobody could plan for.
Rather than your first priority being mission success and getting to the launch pad, your first priority immediately gets displaced, and it's now the safety of the people.
I was seriously thinking Mars would be Mars 2022.
It took a lot of work to put stuff together in order to keep momentum going, to keep people working safely, keep them healthy, and to keep the project on schedule.
There's no doubt that working in isolation, not virtual isolation, but in physical isolation from everyone else, is a challenge.
It's hard for me. I have 2 young kids. Sometimes I'm not able to focus or listen probably as well as I would want to.
A lot of our work was occurring in a clean room anyways, but that meant that even before we entered the clean room, we had to find ways of ensuring that we were not putting ourselves or others at risk.
Most of the time for these missions, our relation with the spacecraft customer is incredibly important. So usually we're able to be here working beside them on their equipment and making sure that all of their needs are covered even before they ask for it. It is a challenge, but we're used to meeting unique requirements here at the hangar, and we pride ourselves in our flexibility.
This is just another mission, just with a different set of obstacles that we have to overcome. It might not be, like a broken rocket, but it's it's got its own challenges.
Our job is to go into the unknown, and this is just another example of the unknown. How to make this job happen when you're doing it largely through a computer screen.
I asked the team a couple months ago if they would like to do something to kind of symbolize and mark these challenges that we faced, and they designed something that we called a COVID-19 Perseverance plate that's now affixed to the port side of the rover. It has a globe representing all of us that face this challenge together, the spacecraft leaving the Earth on its way to Mars, and all of this supported by the now familiar staff and servant of the medical community. And we hope that this mission, in some small way, can inspire them in return. Pretty much everybody that I've talked to that's associated with the mission has said the same thing, which is you could not have come up with a better name than Perseverance.
We have persevered through this. Nobody's given up. We will get this mission done. We will get it done through the pandemic.
I think it's a really important symbol of humanity, hopefully persevering through this great challenging time that we have right now.
We appreciate that team as well as the medical community that really stepped up and helped. And it's ironic, Moo, because the name Perseverance was chosen by a 7th grader who at the time he submitted that name, he didn't know that we would be faced with a global pandemic. So we are glad to have him and his family here along with the student who named the helicopter to watch the launch in person.
Their names are Alexander Mather and Vaniza Rupani, and they are watching from the 5th floor balcony of our engineering building, just a stone's throw away from the countdown clock. Look at that, there they are,
there they
looking
are.
Cool. Alexander Mather, name our rover Perseverance.
Yeah, they've got a great view. I've seen it from up there. They've got the VAB in the background, as you can see there. So
cool.
It's such a beautiful setup for this awesome launch.
All right, we are coming back in right now, just at T-minus 7 minutes and 15 seconds to the launch of the Perseverance rover. You can see the two kids right there who named the rover Perseverance and the helicopter Ingenuity. Very cool. It's awesome. So as you probably heard, we had reports of an earthquake. This was not in Florida, however, this was at JPL in California, where a lot of operations for today's launch are taking place. However, everybody there is doing great, and there is no foreseen delay. So as you can see behind the commentators, it is holding at T-minus 4 minutes. That is expected once the countdown you can see in your top right and bottom right screen reaches T-minus 4 minutes. That countdown will start ticking down to the launch window. So ULA rockets typically hold at T-minus 4 minutes, and this hold has been built into the countdown. We'll still go for launch in 6 minutes and 15 seconds from now at 7:50 a.m. local time.
Launch director. LD is go, and you have permission to launch.
So going back to
Proceeding with the
the
count.
rocket, this is launching on the
ALC, verify
Atlas
T0 is set.
rocket. This refers to a 5-meter payload fairing, 4 strap-on solid rocket boosters, and 1 RL-10 on the second stage. The Atlas is powered by an RD-180 engine and is fueled by RP-1 and liquid oxygen. The RD-180 is derived from the Soviet RD-170, which is the most powerful rocket engine ever made. Centaur is the second stage on today's launch and is propelled by a single RL-10C engine fueled by liquid hydrogen and liquid oxygen. The Atlas V currently has a 100% success rate after 84 flights, and today's launch will be the 85th launch of the Atlas V and the 7th launch for the Atlas V in its 541 configuration. Perseverance will land at the Jezero crater on February 18th, 2021. As you can see, the vehicle is currently on internal power. This transition occurred just at T-minus 5 minutes, so now the vehicle is no longer getting electrical feed from the pad and is on internal battery power. This is the third of 3 Mars missions that have launched this year. The first was the Hope Mars mission for the United Arab Emirates, launching from Japan, and the second was Taiwan 1, which is a Chinese mission which launched from China. You're currently looking live at pad 41 at Cape Canaveral in Florida. It's the same pad that future American astronauts will launch on the Starliner spacecraft from. Very exciting, very, very exciting. So going back to some experiments that will be on the rover, this is the sister rover to Curiosity, and of course has the beautiful, beautiful camera mast on the very front, containing multiple megapixel cameras, mounted with zoom, 3D picture, and all that snazzy stuff. Next is MOXIE, the Mars Oxygen IRSU experiment, which is probably one of the most important experiments on the spacecraft today. This mission will demonstrate the feasibility of converting the carbon dioxide in the Martian atmosphere to oxygen, which will allow humans to breathe on the red planet. And of course, Ingenuity will be the first helicopter to ever fly in space. This is launching aboard the rover and will be the first vehicle to fly in an atmosphere that is not Earth. So coming up on T-minus 3 minutes now, we will come back to you just at liftoff.
As we look ahead to post-liftoff, I want to kind of preview for you what's going to happen because there's going to be a lot going on. You're not going to hear much from us. You'll actually be hearing from the ULA flight commentator, Jesse Gonzalez. He'll be kind of giving those calls past liftoff that will walk us through maximum dynamic pressure and into SRB separation and then into fairing separation, booster separation, and then the first main engine ignition of the Centaur,
yes.
RL-10. And so then you'll kind of hear us jump back in and help provide some more context to what's going on. We encourage you to stay with us for the rest of the show, though. There's a ton more content we have to bring you, and we are far from over. Want to emphasize that the countdown to Mars is not done at 0 today. The countdown to Mars ends in February when Mars 2020 safely delivers Perseverance and Ingenuity to the surface of the red planet. So we're going to let you listen in now and enjoy the last couple minutes of the process of launching a rocket.
One minute 59.
Vehicle internal.
1 minute 55.
Launch sequencer start.
1 minute 50.
Securing Centaur LH2.
Securing Centaur LO2.
So there we heard the fueling is
1
wrapping
minute
up there.
40.
Yep, fueling is wrapping
Launch
up.
enabled.
Team is done. Launch enable's
137.
done. Launch conductor sequence is ready to go. They're getting ready to turn the vehicle over to auto sequence at T-minus 31 seconds. So that's a big thing that they're getting done here. At T-minus 25 seconds, we will hear the team give their final goes that everything is ready and
1
the
minute
launch
20.
vehicle is ready to lift off and
OCU
perform
arm.
this mission.
SCS count started.
1 minute 15.
Produce CCS for launch. Roger.
1 minute 10.
Vent valves locked.
One minute.
Rock, report range status.
Range green.
That's good to hear, Joshua, right
That means
there.
public safety there is accounted for, the FTS system.
Range is green,
There you
go
see on
for
your screen
launch.
a beautiful shot. The skies look great. There is little wind happening. You'd be able to see more of the venting. If there were wind, the trail of that venting. So we're ready to go.
And actually, that's an
40
important
seconds.
point. The reason we don't see that
Stable at
venting is
step
the
3.
vent valves have been locked up to put flight pressure into the tanks. And as we just heard, they're stable at step 3, which means the tanks are ready to go. And here at about 5 seconds, we will
28
hear
seconds.
the team.
ECS reduced for
We have
launch.
entered
Get
launch
right
auto
final
sequence
25
start.
seconds.
This means the
Status
rocket
check.
has taken control
Go
of the
Atlas.
count.
Go
Next
Centaur.
event will be
Go
liftoff
Mars
here
2020.
in T-minus
There we
20
go. We're ready to
seconds.
go liftoff this morning, Joshua.
Minus 15, 14, 13, 12, 11, 10,
7,
9,
6,
8,
5,
7,
4,
6,
ignition, 2,
5, 4, 3, 2, 1. We have ignition of the RD-180,
As the countdown to
and
Mars
we have
continues,
liftoff of the Perseverance rover,
humanity
following
launching the next
Curiosity's
generation
path of
robotic
research
explorers
on the
to
red
planet.
Atlas has cleared the tower.
And Atlas TU has gone to closed loop control. Coming up on 30 seconds into flight, the RD-180 is throttling down as expected. Engine response looks good. And Mach 1.
T plus 30 seconds into flight, everything looking good for launch of Atlas. Booster is transonic.
And passing 45 seconds into flight, vehicle is now passing through max Q, maximum dynamic pressure.
So the vehicle is experiencing maximum aerodynamic pressure. This is the period of maximum aerodynamic stress on the vehicle.
And passing 1 minute into flight, the RD-180 is throttling back up as expected. Engine response looks good. At this time in flight, the SRB chamber pressures remain nominal. The RD-180 pump speed and fuel injector pressures are responding well to demands on the engine. Standing by for SRB burnout shortly.
Everything remaining nominal. SRB burnout here in just about 20 seconds from right now.
And we have burnout on all 4 SRBs. Burnout pressure signatures look good. Standing by for SRB jettison shortly.
And we have SRB burnout. And we have confirmed jettison of all 4
good
SRBs.
Indication of SRB jettison of all 4 SRBs. And the vehicle has gone to closed loop guidance. Vehicle body rates are responding nominally at this time.
T plus just over 2 minutes into flight. Atlas is 135 miles in altitude and 51 miles
coming up on 2.5
downrange.
minutes into flight. The RD-180 is throttled down slightly as expected. Engine response continues to look good. At this time, the vehicle is 50 miles in altitude, 85 miles downrange, traveling at 6,000 miles per hour. And the Centaur reaction control system
So it
is now
looks like that
pressurizing to flight
telemetry in
levels.
miles altitude is actually incorrect.
And just past 3 minutes into flight, the RD-180 is now throttling to maintain a constant 2.5 G acceleration limit for payload fairing jettison. Engine response and vehicle acceleration look good.
We should have fairing separation here in just about right now.
And we have good indication of payload fairing jettison and Centaur forward load reactor deck jettison.
We have confirmation of fairing separation, which was the nose cone of the
And the
rocket.
RD-180 is throttled back,
Perseverance is now
throttling back up
exposed to the
attain a
vacuum of space.
4.6 G acceleration. Engine response continues to look good. And Centaur has begun the boost phase chill down sequence to thermally condition the RL-10 for operation.
And downrange distance of 240 miles.
Standing by for BECO shortly.
And we are coming up on Nico when the
BECO
RD-180
is
on the first stage will cut off and the two stages will separate.
And we have BECO, booster engine cutoff, standing by for stage separation.
MECO confirmed and stage separation confirmed.
And we have good indication of Atlas Centaur separation.
So there you're seeing live footage.
And we
from
have
the
MES
rocket.
1. RL-10 operating parameters look good. Chamber pressures are
The
stable.
ignition of the RL-10 engine. That engine gimbal. It's awesome.
This will be the first of 2 burns for today's
Yes, I know,
mission.
Lance,
This
this
first
is
burn
crazy.
will
It's all
be
Earth.
approximately 7 minutes in length.
So, Mick, that's
Coming
pretty
up on
exceptional
one of the
footage there.
longest
That's
burns of the
live
mission.
video. We will see that switch over shortly into an animation that kind of helps let us know what's happening with the rocket. But right there, a beautiful liftoff. Fun to feel that rumble in the building here as we proceed towards orbit and then towards Mars destination.
Yeah, absolutely. It was great watching an on-time liftoff of the Atlas V with that little over 2 million pounds of thrust. Cleared the tower in roughly 5 seconds. Josh, you and I worked the InSight mission, and if you recall, that mission on the West Coast took about 17 seconds to get past tower. So with those 4 solids today, this thing really got out of here and on its way. And it's, as we hear from Jesse, everything's looking nominal, and all vehicle parameters are within the design limits, and we're getting ready to come up on a main engine start for that first burn that Jesse was talking about.
Yeah, so recapping this countdown to Mars, the stations began to be filled up this morning just after midnight. Preparations, fuelings, powering up, all the way through that liftoff that happened. I think, Mick, it wasn't precise.
Okay, so we just had successful liftoff of the Atlas V rocket from Pad 41 in Florida. You can see the live telemetry there in the bottom left. Unfortunately, it looks like that altitude in miles is showing incorrectly. I'm not sure why that is, but it's out of our control. That's on the official stream.
Things, a lot of wearing their face masks, doing all kinds.
Velocity and downrange distance, so that's correct. So we have a velocity of 14,500 miles per hour and a downrange distance of just passing 800 kilometers.
To see, we still have a long way.
7 minutes in the flight. This first burn will last until just about T plus 11 minutes and 40 seconds into flight, injecting Perseverance into a low Earth orbit.
Is lit and it's firing. So we are in motion. There you go. There's that animation we talked about.
The telemetry there as we switch to a TDRS compatible data format.
Looks like
TDRS
overall telemetry quality is very good.
The space tracking system. So there you go. This is not an actual video, but this is an animation that's driven by real data. So although we're not actually seeing the engine on screen right now, we can see that the engine is lit, and that is driven by the data that says that the engine is truly lit, and we're in this burn.
Yeah, the launch vehicle continues to send telemetry to the launch team via the TDRS network, as you mentioned, and that allows them to continue to watch what's going on and make sure all their sequence of events meet their timeline. We continue on a nominal flight this morning. This first burn, as we heard earlier, will be about 6 minutes. This will get us into that park orbit around Earth, allow us to get on our way, and then get into that approximately 30-minute coast period that we're going to have.
8 minutes into flight, beginning to see the Centaur PU system balance out mass errors, seeing very stable body rates in the Centaur.
So we've mentioned 5 teams at play, and although if you were watching, hopefully you got a chance to see this in person, if not on camera, it's easy to kind of say, oh, it's over, like job done, but all 5 of these teams still very much engaged, still very much focused, because there's a lot of work ahead as we proceed through this first burn, and then a coast phase, like you mentioned, Mick, and then a second burn, and then spacecraft separation and the acquisition of signal from Mars 2020. So a lot more coming up here. Mick, I know for Launch Services Program, you guys manage the launch. So what does that mean? I mean, this is you guys' work in action right now.
By the way, that's the 5th team that we didn't get to mention. We talked about JPL, we talked about DOE, we talked about United States Space Force, and United Launch Alliance. LSP, we are like the brokers to select this launch vehicle and help with manage this mission. So we get our spacecraft customer, the JPL folks, they come to us. They have some certain requirements that they need for this mission. The Launch Services Program made up of engineers and flight analysis folks, and they look at everything, they help define those requirements, and then we go out and procure a vehicle from a commercial partner. In this case, it was the Atlas 541 for the Mars 2020 mission that was needed for performance, right? As you and I have talked over the last several days, Josh, one of the things that was important for us to look at was that performance, to be able to get Mars 2020 onto that transfer orbit into solar orbit to intercept Mars in 7 months. It's kind of analogous to a football game, right? With a quarterback trying to throw a pass downfield. You need a quarterback with a lot of performance who can get that ball down there where it needs to be, and so the receiver can intercept that. In our case, 7 months later.
There you go. Yeah, it's the longest football pass ever. The Earth is the quarterback, the Atlas is the quarterback's arm, Perseverance is the football, and Mars is the receiver.
That's exactly right.
And what we also talked about is that technically you could launch to Mars at any time if you had a rocket that was powerful enough. But this is the launch period every 26 months or so, as we've talked about, that makes the most sense because you require the least amount of energy to to get to Mars because it takes a lot to get there. Obviously, like the Atlas 541 is a workhorse.
Yeah, as Tori said, it's their dominator.
There you go.
I love that name for the Atlas 541. But we heard Jim Bridenstine, our NASA administrator, tell us that if we didn't make this launch period, we would be down for roughly 26 months, right?
Tough.
So the period started July 17th and goes to August 15th. Today, July 30th, was one of those launch opportunities that we had. We had a 2-hour window, and within that window, we had several opportunities.
25, actually. Yeah. 25 opportunities.
And we launched at the beginning of the window on our first opportunity to get Mars 2020 going on its way. And that, that sounds like a lot, and it is. The flight analysis group, both at JPL, LSP, and ULA, did a lot of work to pick out those target sets and figure out where we needed to be. So they've done a great job, and we'll see how this mission continues.
So, Mick, tell us about the 2 burns required here, and we're actually coming up on the end of the first one. Ultimately, a lot of people probably, and myself included at some point, just like, why wouldn't you just keep firing the engines? Just fire all the way through and get to Mars in one shot.
So the first burn gets us into that park orbit we talked about. We've lifted off, we've left Earth, we've got into a park orbit around Earth right now. And while we're in that park orbit, we will perform some maneuvers to kind of roll Mars Perseverance and the Centaur and coast during that time, basically setting itself up looking at the sun and away from the sun to control the thermal environments that are on Mars 2020 during this coast period. That coast period will allow us to coast around into the position that we need so that we can have that second firing to get the velocity needed to head off into Mars.
Yes, and we will be back for that second burn in just under 30 minutes now. But for now, there's more to learn about this mission and all the amazing science that's involved. Daryl, back to you.
All right. Thank you very much. Great launch and great job, guys. Back outside now to recap. An Atlas V rocket carrying Mars Perseverance rover launched on time from the Cape Canaveral Air Force Station at 7:50 a.m. Eastern Daylight Time.
Incredible. After the rocket took flight, it separated from the first stage and was then boosted into orbit by the Centaur's second stage. Perseverance is now preparing for a second burn that will put it on a trajectory toward Mars. That's just incredible to say. It gives me goosebumps.
It really is. And we're so excited about that as well. And while we wait for that second burn, hang in there with us because we got a lot of exciting coverage to go. We're going to welcome in one of our launch guests, Dr. Derek Muller. He is the creator and host of the popular science education channel on YouTube called Veritasium. He also holds a doctorate in physics education, so he's really smart. And that's why you saw us kind of having some fun, because Derek was here on set. We're just having a good time talking about this launch, which I got to start off with that, Derek. Your first time seeing a launch in person, what'd you think?
I mean, what can you say? I have nothing to compare it to, but it was awesome, something I will never forget, and I definitely want to be invited back. So if you guys could make that happen, I mean, just so amazing to see.
You do a great job explaining physics. What did it feel like? Kind of walk me through as you were watching and experiencing it.
Well, it's like all the physics goes out the window a little bit. It's a very visceral moment between you and this very powerful craft. I think it's just amazing all the engineering that goes into making something that's that powerful and yet that controlled, and to witness that is phenomenal. And then to feel the rumble of all that sound as it hits you, I found it an incredibly emotional experience. It's almost unbelievable to see it taking off. It's very surreal, that's for sure.
Nice. What excites you the most about the Perseverance rover?
Well, the Perseverance rover is going to do a lot of great science. So I'm excited, for example, that it's going to cache samples that we're going to bring back. Super excited that we're actually going to have samples from Mars in our hands. And I think that may clinch whether we can see that life is actually there. But I'm also super excited about Ingenuity, about the helicopter, which I got to visit out at JPL before it was strapped to the underbelly of the rover. And to think about flying a rotorcraft in, another world, essentially, in a place that only has 1/100th the Earth's atmosphere. It seems audacious, and I am impressed and amazed, and I can't wait to see if it works. I'm cautiously optimistic. I think the team is phenomenal.
And you did, in fact, a YouTube story on it, a piece on your channel, and did a fantastic job going to JPL.
I did, yeah, and I was just so lucky that it was like there a meter or two away from me on the other side of a door in a clean room, and that was one of the great moments of my life. Yeah,
that thing's going to Mars.
Exactly. Yeah, and it weighs like about as much as my laptop.
Yeah.
And you think about it's substantial in its size, and it's going to go there and take off and fly all by itself, because of course we can't control it given the time delay and everything. That is, I just think, one of the pinnacles of human engineering.
Yes, absolutely. Now, this is going to do some big science as well. What are your thoughts on the search for ancient microbial life on another planet, Mars?
Well, I think chances are good that Mars once harbored life. It was so similar to Earth in the past. One can only expect, life probably sprung up there as well. But I'm really excited for us to get that confirmation, because I think it really transforms our ideas about life and how frequent it is. Right now, all we have is this sample size of one Earth with life. If we find another one, that's 100% more information and data, and I think it's likely that life will not be exactly like ours. And I think it'll be fascinating, everything we can learn about other potential forms of life just by finding life on another planet.
You seem to suggest that you think there is life.
I do. I mean, you have liquid water for I don't know how many, half a billion or a billion years. On Earth, that was enough to create life. So, the guess is that's not a unique thing, right? I mean, the scientific hypothesis is you run that enough times, it's bound to lead to life again in other circumstances.
Dr. Derek Muller, we really appreciate you being here, YouTube creator with the channel Veritasium. We know you have a 2.5-week-old child that your wife is holding out.
There are very few things that I could leave for, but this launch, that is one of them.
Thank you so much for doing so. Get a selfie with our full-size rover back here. You see that?
Please.
I definitely will.
Very good. Thank you so much.
There has been a lot of anticipation by NASA teams leading up to this launch, but some won't be able to fully celebrate until the rover has safely landed on Mars 7 months from now. Raquel, you're there with the Mars mission team at JPL in California. How are they reacting to seeing Mars 2020 take flight?
Well, Moo, it's been quite an eventful morning with the earthquake, but you could feel the energy building in the room in the run-up to launch. And now I'm with Bobby Braun, the Director for Planetary Science at JPL. Bobby, now that we've started our journey to Mars, can you tell me how you are feeling?
Wow, it's a great day. We're all so excited, and to get started in this way and to be on our way after all this work that the team has gone through. It's really just fantastic.
That's great. Now that Perseverance is off the launch pad, what are its next steps?
Yeah, well, we're almost on the path to Mars, if you will. The launch vehicle has done great so far. Our partners at ULA are just fantastic, and we're very happy to be working with them and for them to give us this boost so far. But we still have to have another burn of our upper stage. We have to pass through the night side, or the shadow of the Earth, come out on the other side and find the sun and power up, and then establish contact with the spacecraft. And once we do, we'll truly be on our way to Mars. We'll have a spacecraft that's power safe, that we can communicate with, and our journey will really begin.
We look forward to that. Thanks, Bobby. Now, Daryl, as Bobby mentioned, there's an excitement here in the room as the team looks ahead to the second Centaur burn. But before we get to that, let's learn more about the science on board this rover.
All right, thanks, Raquel. And as you mentioned, there are numerous scientific studies and technology demonstrations on Perseverance. Some of these are directly preparing us to one day send humans to Mars. One in particular is called MOXIE. Jeff Sheehy from the Science and Technology Mission Directorate is joining us now to explain, and he is here with us. Sometimes here at the...
A little difficulty with this technology
that's all
here,
right.
Daryl.
Well, that's all right. It's a Britney Spears style mic,
So like this.
I don't know if you're... That'll work fine. We can hear you. Yeah. Thanks for making the adjustment there. So, Jeff, this is an incredible piece of technology here, this MOXIE, right? So tell us, what is it and why is it important?
Well, MOXIE stands for Mars Oxygen In Situ Resource Utilization Experiment. That's kind of a mouthful, so we grab a few letters out of there and just call it MOXIE. And I think the name MOXIE has a certain kind of attitude that's appropriate for this ambitious mission to Mars. But what in situ resource utilization is utilizing the resources that we find at a destination to produce useful commodities. And so what MOXIE's going to do is suck in the Mars atmosphere, which is mostly carbon dioxide, and produce pure oxygen. Oxygen is a commodity that we can use in our exploration endeavors, and so MOXIE is the first in situ resource utilization experiment on another planet.
How about that?
So that's why it's so important. If we can produce things we need at the destination, we don't have to load them in a launch vehicle, launch them from the surface to Earth, push them all the way to the destination, and land them on Mars or the moon.
Saving incredible weight, fuel, resources to
Exactly.
use them, the ones that are there and in place.
That's right. It took a lot of moxie. What were some of the biggest challenges in developing this technology, designing it, developing, building it?
Well, the team that produced the hardware that we just saw being launched on its way to Mars, they certainly had moxie because they had to overcome a lot of challenges along the way. When you start to develop new technologies, you're working in a laboratory and you've got all the room you need usually, and you can build it big and heavy because you're not trying to make it look pretty, you're just trying to make it work, and you've got all the power you need, and you can control the thermal environment, and you can have teams of people come in and tinker with it and fix it when it breaks and all of that. So, but and you can probably see where I'm going with this. When you get to the point where it's time to fly that hardware to prove it out in the space environment or on the planetary surface, then the rubber really hits the road in terms of the engineering, and that's where the teams of engineers come into play, and they develop clever solutions to implement the process that's been developed in the lab and package it for space flight. So MOXIE faced a lot of challenges. You know, once you have to put it on the rover, the size becomes important. It has to fit in a certain volume on the rover. The amount of weight or the mass becomes really important. Every ounce you launch into space takes propellant to move it. So we want to make MOXIE as light as possible. Had to fit within a certain mass budget, or they would have kicked it off the rover.
Yeah, and we're glad you made it on the rover.
Yes.
And just real quick, and without getting too deep into the technical details, how does it convert carbon dioxide to oxygen?
So MOXIE uses a thermal and electrochemical process. There's a compressor that was built by a company called Air Squared. Some of that was funded under the NASA Small Business Innovative Research Program, actually. And they built the compressor. What it does is acquire the carbon dioxide from the Mars atmosphere and push it into the electrolysis system. A company called Ceramatech, a team led by a guy named Joe Hartvigsen. They're now called Oxyon Energy, I think. But they built the guts of MOXIE, which is the solid oxide electrolysis system that takes the carbon dioxide, CO2, actually pulls an atom of oxygen off the CO2, leaving CO.
Oh, wow.
And then those atoms migrate through the electrolysis system, and those oxygen ions are neutralized, and then they recombine. An O and an O becomes O2. And so we get pure oxygen out of the system.
That's fantastic. And so in order for you to get MOXIE on board the rover, actually you had to kind of clear through the very smart lady to my left. She's with Planetary Protection. So she actually had to clean off part of it, right?
Yeah.
You had to heat it and then clean the
That's
O2
right.
sensor.
Yeah, the SOx part was actually self-sterilizing. It was hot enough so it cleaned itself. But there's a part, the O2 sensors, that needed vapor hydrogen peroxide sterilization. So it was the first time we used hydrogen peroxide on flight hardware.
Oh, that's awesome.
Yeah.
So you can say thank you.
Thank you.
Thank you. No, thank you.
Appreciate it very
Thanks for
much.
letting us do that.
Well, you know, in speaking about the rover, Moo, what is it, you know, Curiosity told us that we have, or had at one time on Mars, moving water.
That's
so,
right.
So what is Perseverance going to do in terms of confirming whether life could have been there?
Yeah, exactly. So the past mission set up the stage as far as understanding what could sustain life. And now we're actually looking for signatures of that life.
And so some of the answers that you're looking for, which one are you personally looking most forward to?
Yeah, I'm personally looking forward to seeing signs of life where no one will argue that it has a biotic source. It's very easy to say, oh, this chemistry could have happened from natural reasons, but I want to see a smoking gun. It would be awesome to see that.
Now, that's not exactly easy, right?
No, not at all.
And so explain that to us.
Yeah, so in order to get that definitive signal, one of the main things you have to do is make sure you have a clean instrument that you're sampling with. And so that's why we spent a lot of time cleaning, baking out hardware to such a high degree, 150 degrees Celsius for some of these parts, to make sure it was clean enough.
And so those parts have to be specially made to be able to handle that heat.
That's right, yeah.
In order to get it past you.
Yeah, all of the material selection, everything was done specifically for that purpose.
Where else in the universe, Moo, do you think we should explore for life?
Yeah, I'm really excited about Europa. Europa has an ocean underneath a thick layer of ice. It has vents underneath that have a heat source, so there's a source of energy for possible life.
Europa, a moon.
Yes, a moon. Yeah, icy moons. That's the next place to go.
It's interesting that you picked that. I mean, it's a very, very cold, cold place.
Yeah.
You've got a rover in front of you that is miniaturized.
Do.
We have one that is behind us.
Yeah.
Right. And as part of this, you also had to make sure that nuclear battery was installed.
Exactly.
Yeah, there it is.
Yeah. This bit back here.
Tell me about how that worked, when you did it, and how that process was.
Yeah, it was only a few days before this launch day. I mean, we just finished counting our samples just a couple of days ago.
How about that?
Yeah, so we had to actually alter the way we sample. We take wipes and swabs of every surface of the rover. But for this, we had to make sure our head was far back and we had as minimal radiation impact as possible. But we got it. It was super clean. INL did a great job. Everyone has done a fantastic job making sure this was as clean as possible.
It's ready to go. What do you think about that full-size rover behind us?
It's incredible. It's like, hey, you should be up there.
And apparently it is right to scale as you take a shot of it there. That's a beautiful rover. Well,
it is.
Thanks for describing all that to us, Moo. We really appreciate the time for you describing that. All right, back into the show now we go. Moving forward, of course, this is the countdown as we go up. You can see the Centaur there in the graphics as we are tracking and continuing to track Mars 2020 on its way. And when searching for the possibility of life on Mars, it's all about location, location, location. And Perseverance's destination is a place called Jezero Crater. Let's go back out to JPL now. And Raquel, you've got a scientist there that believes Jezero Crater gives them the best chance of finding any evidence of past microscopic life.
That's right, Daryl. Knowing where to look for signs of ancient life on Mars can be a daunting task. It took 5 years to select a perfect landing site, and with us now is Katie Stack-Morgan, one of the project scientists who helped pick that location. Katie, can you tell us why we're heading to Jezero Crater?
Thanks, Raquel. There are many reasons why scientists are so excited to send Perseverance to Jezero Crater, and why we think that Jezero Crater is an ideal place to begin a Mars sample return campaign. At Jezero, we think that Perseverance can assemble a diverse set of samples that will help us resolve some of the most important questions about life beyond Earth and the evolution of planets over time. At Jezero, we know without a doubt that there was an ancient lake and river delta. And at Jezero, we have river valleys that flow into and out of the crater, and we know that that lake filled up with water and then overflowed. Life as we know it requires water to survive and thrive, and we think that Jezero has all the building blocks to support past life. At Jezero, we also have one of the best preserved deltas on the surface of Mars, and deltas in lake settings are ideal for supporting life. And the rocks that Perseverance will explore can tell us more about the possibility for past life on Mars. The rocks at Jezero Crater are also some of the oldest on Mars, between 3.5 and 4 billion years old, and that's the same interval of time when life was developing here on Earth. So by exploring the rocks in Jezero with Perseverance, we have the opportunity to explore more about the development of life in the solar system and can answer some of the major questions we have about that fundamental question. Back to you, Raquel.
Great. Thank you so much, Katie. And with that, let's head back to Kennedy Space Center. Daryl?
Much, Raquel. We are back here at the Kennedy Space Center with our most special guest, Moo, and the Perseverance rover. Here it is, a full-scale mock-up of the actual rover itself. Well, Moo, here it is.
Yes.
And so we've learned a lot about this rover so far. So tell me kind of describe from top to bottom what we're working here. At the top, you've got the mass cam, which is pretty tall, right?
It is very
it's
tall.
Towering over your head. It is on a stage, but what does it do?
Yeah, so it has a lot of fun components. Some of them are the Mastcam Z. Z stands for zoom, so you see those two stereo cameras. And there's also that eyeball, what looks like an eye, is actually a laser. It shoots at the rocks.
A laser.
A laser, lasers. And then depending on the signature that comes back, the spectrometer reads it and tells you what the geology is.
And that's fantastic.
Yeah.
Some of the real exciting science, though, is happening right here on this part. This is the articulating arm that comes out, right, and then goes down onto the planet and starts drilling.
Exactly.
What all is here that's going to help us understand more about the geology of Mars, the climate, and whether or not there was life?
Yeah, there's of course Pixel and Sherlock, the really amazing instruments that are going to tell us about the biosignatures. But in the middle, there is the coring drill. The real drill will have a drill bit, a coring bit, which is hollow in the middle. And there's going to be a tube inside. This is just a 3D printed version. And as it's collecting samples, it's going to have samples that go directly into the tube.
Oh, you've got a tube there. Yeah, show
here's
that
a
the camera
3D
there.
printed tube here.
Yeah.
And it's going to go down the middle of the tube as it's acquiring the sample. Once it's done, it's going to dock with the bit carousel here. It's going to ingest the entire bit with the tube inside and the sample. It's going to rotate down to the belly, and there's going to be a little arm on the inside called the SHA, the sample handling arm, to manipulate it, take pictures, assess the volume, and then seal it.
That's fantastic. And so there's quite a bit of robotics happening between this part, the bit carousel, and getting it underneath. As we know, it's now underneath. But here's a special guest, and we're going to duck down. This is the Mars helicopter.
Yes,
and
Ingenuity.
This thing is going to be actually tucked up underneath the rover. It was a late addition to this project, but it's probably one of the neatest things on it.
It is pretty amazing. 2,400 RPM that these blades are going to spin in counter directions.
Yeah.
It's a little bit under 4 pounds. It's super light. And yeah, it's going to be the first rotorcraft flight on the surface of Mars. It's spectacular.
And you know what's amazing? It will be taking pictures as well, right?
That's
Look
right.
At the blades.
Wow.
These blades turn,
Great
right?
model.
And they turn in opposite directions.
They
I
do.
understand.
They do.
It will have a camera on it. It will shoot live or shoot video.
Yes.
That we will then get back. It'll shoot video of the rover as it's doing its work, right?
Yeah, it's spectacular. And look at the clearance. I mean, this rover needs to clear this helicopter after it's deployed.
All right. Well, thank you so much for giving us the tour of the mock-up. It's just like the real one, except for it's not going to Mars. Well, thank you so much. And so by now you may have heard that this Perseverance rover was named by a 7th grader. And it was given that name, which is very special to us. And so we asked Hidden Figures actress Octavia Spencer to tell you why the Perseverance name is more than just a name to us here at NASA.
We are a species of explorers, believers.
We choose to go to the moon in this decade and do the other thing, not because they are easy, but because they are hard.
We are willing to do the hard things, to overcome the many challenges. This is what brings out the best in us.
We are go for a mission to the moon.
Our path has led to success and to bitter losses.
We come together today to mourn the loss of 7 brave Americans.
Yet, even when faced with tragedy and setbacks, we persevere. We keep striving. We keep believing. From space, we see our planet as a whole. We see the challenges facing it, and we face those challenges together. We will not give up. We challenge convention. We refuse to accept the status quo. The time at hand is hard, but we will persevere. We can still draw hope from the moon and the stars, from space, from exploration. There is a new day beyond the challenges we face now.
Curiosity, insight, spirit, opportunity. If you think about it, all of these names of past Mars rovers are qualities we possess as humans.
10, 9, we have ignition sequence start.
But if rovers are to be the qualities of us as a race, we missed the most important thing.
3, 2,
perseverance.
Launch commence, liftoff. We have liftoff.
We are a species of explorers. We will meet many obstacles on our way to Mars. But as humans, will not give up. We will always persevere.
Our collective perseverance is what has gotten us to this day, and now Mars 2020 is on its 7-month journey to Mars with an anticipated landing date of Perseverance on February 18th, 2021. Now we are joined by Dr. Thomas Zurbuchen, Associate Administrator for Science at NASA. Dr. Z, thank you so much for coming over here.
God, I'm so glad I'm here, and I'm so relieved. You know,
Yeah.
we have a space mission, and we're in touch with the spacecraft, you know, and everything is nominal. We're waiting, of course, for the second burn, but not
Exactly.
quite there, but we're really close.
Yes. So can you tell us what makes going to Mars incredibly hard?
So there's really two pieces that make it hard. The first one is what we're doing today, which is you really need to head in the right direction.
Yeah.
So take it off the Earth and have a lot of energy and head exactly in the right direction, because what you want to make sure is in February, when Mars comes, you want to be right there so you can get captured. The second one, which is the one that's going to make us nervous in February, is to entry, descent, and land. You know, so the Mars atmosphere is almost the worst of all worlds. If it was really thick, you could do what we're doing on Earth, which just go in and with parachutes.
Yeah.
If there was none of them there, you could do, you know, what we do at the moon. When in Mars, you have to do both on top of each other, which makes it 10 times harder than any of the other two, and so that's what makes it so hard.
Wow.
You've devoted much of your life to science, and I know you were asked the other day during a news conference, you know, why another rover, and you gave a pretty impassioned response. Why is this rover important in your mind to the work that so many people are doing in science?
So it's really kind of a key of a whole bunch of new research that we're doing that is focused on a question that for thousands of years philosophers have asked, scientists have asked, and we're ready to answer with the tools of science, which is the way to get reliable answers. And that is there life out there? We have, for 20 years, we've learned about the environment at Mars, and we're ready to ask that now. And the way we're doing it is with this rover. So it's really, for the first time in decades, the first astrobiology mission. We're ready for it, where it's the next step, and of course there's others coming, you know, Dragonfly, we're already thinking about, and you know, other missions. We want to, of course, go to Enceladus in Europa, you know, and really learn about life there also. So it's an amazing first in that respect.
And whether there's life there or not, that's going to be the answer that we're looking for in these places.
So yeah, exactly.
Yeah, and so we want to do a social media question real quick, if that's all right with you.
Oh, absolutely.
All right.
We have a question from Twitter. What is the key difference between previous NASA missions, rover missions, to Mars, like Spirit, Opportunity, Curiosity, and Perseverance rover? In what way is Perseverance unique from the previous ones?
So there's a fundamental difference in the approach. And the fundamental difference is that we decided to put the instruments on Perseverance, the best geology instruments on this, so we can find the right samples. And we decided not to put a chemistry lab on it. Guess why? We don't know which one yet. And so what we're doing is we're actually collecting the samples that we're going to bring to the best labs that are available to humanity, which are the labs all over the world. And that's the choice here. And that's, of course, to do that, we need to do another first, which is humanity's first round trip to another planet. And that's what makes it different.
We've got more with the launch operation to go, but real quick, how'd you feel about that launch?
Oh, I loved it. It's like punching a hole in the sky, right? It's really getting off the cosmic shore, our Earth, into wading out there into the cosmic ocean. I just love it every time it gets me.
All right, very good. Dr. Thomas Zurbuchen, thank you for joining us. We appreciate you being here to explain all the science and the excitement that's coming up.
Thank you so much.
Appreciate it. Now we've talked to scientists and engineers, and we have shared highlights of the mission and tech demonstrations that are central to the Perseverance rover. And folks, we have a lot more to share.
Mars Perseverance has been flying in space for more than a half hour now. Let's check back in with Joshua and Mick to recap the flight so far and tell us what's coming up next.
Hey, thanks, Moo. Yeah, as you're seeing on screen there, that is, again, the animation of the Centaur in motion around Earth, in orbit around Earth. And you can see there, like I mentioned, the animation being driven by real telemetry data. Mick, how is the report coming back from the first burn and then currently our coast phase?
So we're hearing from Jesse Gonzalez and the engineering team is that everything so far has been nominal. Centaur's been performing well. All the settling firings have been going great, which is keeping the fuel that's still in the tank where it needs to be as we get ready to come up on main engine start 2 for that second burn, which is very important to get us our velocity and into that transfer orbit to Mars.
Yeah, so that will be up in just a few minutes, but I think we're going to actually send you back out to our main desk to hear. Oh, sorry. I'm being held. We're going to hang out here. So coming up, talk about C3, Mick. This is something that we talked about having to do with the energy to leave Earth and go somewhere else. We're talking about having to get to speeds over 25,000 miles per hour. That's Earth's escape velocity.
Yeah, so C3 is basically just the technical term that we use in the aerospace industry to refer to the velocity that we need to get the vehicle where it needs to be. So as you said, we got that little over 2 million pounds of thrust that we left Earth this morning with those mighty 4 solids on the Dominator. I still like that from Tori Bruno. Tori, I'm gonna take that one from Tori. But we got off here and into the park orbit with the proper velocity we needed. And then, of course, this second burn is so important for the velocity we need to get in transfer orbit.
Awesome. So the Dominator punching a hole in the sky, as Dr. Zurbuchen said. So we will send it back out now to the main desk and be back with you in just a minute to catch that second burn. Daryl?
All right, thank you very much.
Thanks so much, Joshua. Joining us now to talk about how special these missions are is Dr. Michael Watkins. He's the director of the Jet Propulsion Laboratory in California, which planned Perseverance's mission to Mars. That is my home center. Thank you for joining us, Dr. Watkins. My pleasure. So we have so many great questions for you. Why are missions to Mars unique?
Well, I think they're unique for 2 ways. I mean, one is just Mars. It's been in our imagination for centuries. It's a place that looks like the Earth. It looks like it could be home to us. It looked like it was once home to to what could have been life. And the fact that we can get there, and we can get there every couple of years, and we can send missions, and we can build on those missions, and you can learn from your mistakes. You can learn from your successes. One of the things I like to joke about is, we say Perseverance looks like Curiosity, but the people who built them are the same. They look even more like each other. And so they, so a lot of our folks worked on Mars Pathfinder, they worked on Spirit, Opportunity, they worked on Curiosity, and now Perseverance. And that, that history, that group of folks, they're just world leaders, and it's why we're successful.
So you're stream.
We're live.
And we are back for coverage of the transfer burn to Mars. This transfer burn should be starting here in just about 3 minutes. So the RL-10 engine on the Centaur upper stage will ignite, propelling the Centaur and Perseverance to a Hohmann transfer. That is the transfer orbit to Mars. This burn will add roughly 3 kilometers per second of velocity to the spacecraft. This burn will last roughly 6.5 minutes. And we'll start in 2 minutes from now. As you can see on your screen and the animation, those little white plumes that are coming out the very bottom of the Centaur, those are the reaction control system thrusters firing to keep the fuel at the bottom of the tanks. So when the Centaur, or when the RL-10 engine does ignite, the fuel is not just floating around in the tank, because of course they are in 0G in the vacuum of space, and the liquid in the fuel turns into a bunch of drops inside the tank. So firing those tiny, tiny thrusters pushes all those drops to the bottom of the tank and allows the fuel to flow into the engine. Now just T-minus 60 seconds from the transfer burn start.
of that Centaur RL-10 engine. Again, Mick, explain what this second burn is for.
So as we talked earlier, the second burn is really to get us that velocity as we head into that transfer orbit, right? Centaur and Mars 2020 will head into that solar orbit on its way with the proper velocity. We will then get ready to separate Mars 2020 on its way. And I'm hearing that settling is done
and we have main engine
start.
There we go. Awesome. And again, that animation there being driven by actual telemetry data coming from that rocket. So that's a phenomenal sign. And again, I think that it's tough with these images. Perspective and scale are so important.
The spacecraft, sending it to a home and transfer.
And it does look like our countdown is behind by about 15 seconds. So just keep that. And by that I refer to the times I have in the bottom right.
Oh, yes. So our so where it says second stage cutoff at 52:59, that is going to be just about 52:45 roughly. Looks like the launch times changed just a little bit since the press kit was released.
Denton Gibson, excuse me. Yes. He is a rocket scientist. His official title is Senior Vehicle Systems Engineer. Denton, how are you doing?
I'm doing well. Thanks for having me.
Yeah, did you enjoy that? Obviously, you got to kind of spectate. A lot of days, you guys sitting on console, you have to kind of focus on your computer, but you got to see this one today.
Oh, yes, and it was a beautiful launch today.
Yeah, nice sunrise. Hey, tell us about your role with LSP. I was not making up things when I said you're a rocket scientist, but what exactly do you do?
So as our role in LSP, as a vehicle system engineer, we are the engineering team lead for a lot of the rockets that we launch our science missions on. And we are responsible for the oversight and insight into these launch vehicles for the NASA.
That's awesome. And I know in the past you've supported a variety of vehicles. Tell us a little bit about the vehicles that you have supported and the ones you're focused on today.
Yeah, so some of the vehicles I supported in the past is the Delta II, which was a long-time workhorse for our science missions, as well as the Pegasus and Taurus/Minotaur C. And right now I've been focused mainly on the Falcon 9 and Falcon Heavy.
Yeah, awesome. So obviously not focused on the Atlas V, but a lot of that experience and the process is the same. I want to take a moment to pause and say Denton's there at Hangar AE. That's the NASA Launch Services Program's hangar. They're very proud of that. We call it the telemetry center of the universe. That's where the data for today is flowing. But I wanted to also ask you, is the process the same for all these vehicles? When we talk about the telemetry and these sort of processes of getting from Earth to Mars, does Falcon 9 experience translate to Atlas, or are they completely separate?
So the overall process for many of these launch vehicles are the same, whereas you ship stages to the launch site and assemble the launch vehicles by stages. So in that sense, they're the same, but there's a lot of differences between the launch vehicles that may change that process a little bit. But in general, the processes are the same.
Yeah, and Joshua, I was going to say, Denton, I work with Denton quite a bit over the years, and he talks about the different vehicles he's worked on. But Denton is one of my senior vehicle engineers in LSP, and so although he's not totally supporting Atlas V today, he does have experience with Atlas V, and as he said, things are very similar. So using his experience, we're able to train and bring on new generation of engineers, and Denton's been a huge part of that to allow us to grow our bench, if you will, to start working commercial partners.
Yeah, awesome. So Denton, tell us a little bit about kind of what's involved, what goes in behind the scenes, what's the rocket science of going from Earth to Mars, this maneuver to go into solar orbit?
Yeah. So a lot of the things that happen behind the scenes it's a lot of analysis work done by our analysis teams. I mean, it's months and months of analyses that are performed based on the orbit insertion, the performance of the launch vehicle. A lot of modeling and simulations is done to be able to get to this point to where we can transfer from Earth orbit into solar orbit.
Awesome. And obviously, you're a rocket scientist. That's for a lot of people, that's like the pinnacle. That's like, hey, I want to be a rocket scientist. So where do you go from here in your career? Because obviously, I'm sure there's lots of things that you'd like to go and accomplish.
So, going from here, one of the coolest things about this job, working in the launch services program, is working the launch, right?
And we are just about halfway through the Centaur burn. Centaur has added about 1.5 kilometers per second of velocity to itself. Currently, we are about halfway through the burn. In just about 3 minutes, we will have a Centaur shutdown.
Launch manager as today we talked, right? Omar Baez is our launch manager for Mars 2020, and he had to poll the team and make sure everything's ready to go. So the buck does stop with him right there on today's launch. And as Denton says, I think there's a lot of people that would love that job, and Denton's definitely looking at that next step. So I guess we need to give Omar and his assistant launch manager Tim Dunn a heads up.
Yeah, there you go. Dr. Gibson.
Dr. Gibson is
Up
on
and
the
coming.
way. Yeah.
Awesome. Well, Dr. Gibson, before we let you go, give us a real quick snapshot. I know you have a mission coming up later this year. What are you working on?
So we're supporting the Crew 1 launch coming up. So we're helping commercial crew out with that one, as well as Sentinel-6 as far as the LSP missions that's coming up later on this year. And so we're excited about that one.
Yeah, a ton going on. Dr. Gibson, appreciate you. Thanks. And I want to take a special moment on the commercial crew note to comment. We've got a big day coming up.
Yes.
Pending weather. There's a tropical system that might kind of get in the mix here. But we have a tropical system that could create some problems. Otherwise, we've got Bob and Doug from Demo 2. They're coming home on August 2nd.
Yes, I was going to say, Joshua, that's important for us also in LSP. Denton was my lead VSE, along with a few others that are in the group that worked that mission with the commercial crew program. And so it's really important for us to be able to support other programs within the agency to make these things happen. As we launch Mars 2020 today, which is another step for us getting humans to Mars, right, is getting humans launched off of Earth soil was a huge step for off of American soil.
Yes.
was a huge step for us.
Yeah, and so talk about that really briefly with LSP. Obviously, Denton there, appreciate him and his contribution, and you working towards commercial crew, but also supporting Artemis, which is also part of that path of getting humans to Mars someday. Artemis is about learning to live on the moon to sustain a presence there with the eyes on Mars. So how is LSP supporting even Artemis?
Yeah, one of the things there is the Gateway program, right? Deep Space Logistics that is working a lot of that. And so LSP is in the works of supporting Gateway and helping them work with the commercial partners that are providing the rockets for those kind of missions that are out there and future things. One of the cool things about working with the Launch Services Program is that we work with all of our commercial partners, SpaceX, United Launch Alliance, Northrop Grumman Space Systems, and of course some up-and-coming.
And we should have cutoff here of the Centaur engine very, very soon. The vehicle just reached escape velocity, so the vehicle is no longer bounded by Earth's gravity. Well, it is, but is now on a path to escape Earth's gravity well, and should be on a path to Mars here in just about 20 seconds. One crazy thing about this rocket is it's traveling 10 kilometers per second. It's absolutely a mind-boggling speed. 10 kilometers per second, not 10 kilometers per hour, 10 kilometers per second. Every second you count, it is moving 10 kilometers. Absolutely amazing. And looks like we have confirmation of RL-10 shutdown. So coming up in about 5 minutes, we will have spacecraft separation, and we will be back to bring you that live.
Yeah, so the important thing this morning is when we lifted off from Complex 41 here at Cape Canaveral Air Force Station, we had ground stations that were looking at the launch vehicle and tracked it all the way to provide data. Once we got onto orbit after stage separation, you heard a call out for TDRS, the telemetry network that NASA owns, which, by the way, is also used for the ISS and will be used hopefully for the landing with Doug and them. So getting off the ground today was great because we could deconflict some of that TDRS usage, right? But TDRS is very important for us to be able to get the telemetry from the launch vehicle back down to Earth here. And then, of course, when Mars 2020 separates and it gets on its way to Mars, then the JPL team will take advantage of NASA's Deep Space Network, which has been around for a long time, to be able to transmit commands and data back and forth to the Mars 2020. So TDRS and Deep Space Network are very important to not only the science missions, but human spaceflight also.
Yeah, and I think the coordination of that is something that people don't get a chance to understand much because, as you said, we're using TDRS for crew return, we use TDRS for space station, and TDRS is not an unlimited resource. We have a good number of TDRS satellites in orbit that help us do these things, but it is a coordinated effort across the globe because we even have ground stations in Australia, I think.
Yeah.
Where are all of our ground stations even?
We have ground stations everywhere, not only here in America on the West Coast and East Coast, but then you get into South Africa area, Australia, you said. We have several ground stations that catch up different things for missions. But, of course, in orbit, TDRS and the Deep Space Network are very important. And as you said, there's not an unlimited amount of resources there in the TDRS network. So we have to coordinate those things within the NASA agency and with our commercial partners when they're used for our launches. And again, that's another part of what NASA does as an agency.
Yeah, so just on that note, kind of thinking about around the world, currently this spacecraft is roughly over the South Indian Ocean. So that's just thinking about how fast we're moving, just the amazing world of spaceflight. It's just hard to put into words sometimes of like we're literally flying around the Earth and we're already halfway around it. And so I want to talk actually about planetary protection some more. I know we heard about that a little bit from Moo, about how they're working to protect Mars from contamination, so to speak, just putting things there we don't want. And we have to consider that, or ULA has to consider that when they're flying to Mars and delivering the spacecraft.
Yeah, it's a combined team. ULA, JPL, LSP had to look at that for when we get ready for spacecraft separation here in about a minute, right? One of the things we talked earlier is that Centaur and Mars 2020 are on the same path towards Mars right now. So once we separate, Centaur will do a CCAM maneuver, or what we call a contamination and control avoidance maneuver, and then blow down what's left of propellants in its tank. And by doing that, we have now put Centaur on a different track so that it will not intercept Mars or interfere with Mars 2020 at all for approximately the next 50 years.
Yeah.
And that took a lot of work by the JPL team and the launch team to make sure that would happen. So again, another planetary protection maneuver that had to be done.
Yeah, and I understand from the telemetry experts in LSP that this rocket actually, after the second burn, is not actually aimed straight at Mars for that reason. It's actually aimed slightly off of Mars. And so Perseverance, Mars 2020, will redirect itself just slightly. We're not talking about over 7 months. A little bit of difference here makes a lot of difference later.
Absolutely. And Josh, we heard Jesse telling us that Centaur is spinning up. This is the maneuver right prior to spacecraft separation, where we get into a slight roll to give Mars 2020 some
stable Centaur tank pressure,
stability.
Very good performance from the RCS system, and stable indications from the avionics systems as well.
So RCS there, the reaction control system, that's those small, the series of those small engines that you see firing around the spacecraft. Those are used for that in-flight operation. As Mick's saying, it's basically providing stability to the flight of Mars 2020 as we go forward. Tell us about actually.
And we are back. We are just about 20 seconds away from spacecraft separation. And there we go. We have confirmation of spacecraft separation. Awesome. Look at that. It's unfortunate we don't have any live shots of that. But we should be getting a visual confirmation here very, very soon. And yes, we have confirmation. Separation has been confirmed. Atlas has done its job today. Amazing liftoff at 7:50 a.m. at Cape Canaveral. Yeah. So this is going to conclude our coverage for today's launch. Hope you all enjoyed. If you did, make sure you subscribe and leave a like. That really helps us out as we're trying to grow our channel. And yes, we will be back for the next launch.
So that's the end of ULA's job for today.
Jesse Gonzalez did a great job with ULA commentary this morning. But what I was saying about the Mission Director Center is normally we would see a lot of clapping, a lot of hoop hollering, a lot of handshaking.
Yeah.
But with the pandemic and everything, people are staying their distance, taking the guidelines seriously.